Imagine your phone or laptop starts slowing down because it's getting too hot. Or worse, the chip inside starts to fail. That's a problem almost every electronic device faces. Scientists just created a new material that could help solve it. It moves heat away from the chip much better than older materials, and it's soft enough that it won't damage anything. Here's how it works. Inside your devices, the chip that does all the work gets hot. To cool it down, manufacturers place a heatsink on top of it, but between the chip and the heatsink there are tiny air gaps, and air is terrible at moving heat. That's why they use special pastes or pads. The problem is that most of these materials force a tough choice. If they move heat really well, they're usually hard and don't fill the gaps properly. If they're soft and fill the gaps perfectly, they don't move heat very efficiently. Until now. A team of researchers in China developed a new material that does both things at once. They used special carbon fibers that are excellent at carrying heat. Then they connected those fibers using a tiny amount of graphene oxide, a material related to graphite. This glue helps the heat flow smoothly from one fiber to the next, instead of getting stuck. The whole structure is then filled with a soft silicone so the final material stays flexible. The result is a pad that conducts heat far better than regular silicone, while still being soft enough to press into those microscopic gaps without putting stress on delicate parts. In tests, this new material moved heat more than 40 times better than plain silicone. It also performed significantly better than similar materials that used older types of binders. Even with the extra carbon fibers inside, it stayed soft and flexible. It could be compressed repeatedly without breaking down, which is important for real-world use. In simple terms, heat leaves the chip faster, the material fills the gaps cleanly, and it doesn't damage the components. Better cooling means devices can run faster and more reliably. This is especially useful for powerful electronics, things like high-end computers, servers, AI chips, and future phones that pack a lot of power into a small space. Overheating has been a long-standing bottleneck in electronics. Materials like this one help remove that bottleneck without adding bulk or risk. The researchers say they plan to improve it even further so it can handle even more demanding applications. This is one of those quiet engineering advances that most people never hear about, but it affects the devices we use every day. If you'd like me to explain more about how modern electronics stay cool or other materials that are changing technology, let me know in the comments. And if you found this interesting, hit like and subscribe. See you in the next one.